Hello everyone, today we're going to be working on problem 4.174, and this problem is telling us to determine the magnitude of the equivalent resultant force and specify the location of the resultant force on the beam measured from point A. So to determine that resultant force, or that, I guess you could say in another ways, the concentrated force, what we're going to do is we're going to be using this equation. So as you can see, we have our integral where x will start at 0 all the way to the span or the length of the beam. Then we have our distributed loading, or the line load acting on the beam, and then dx. So we're simply just going to plug in everything that we know. So we know that the beam goes from 0 to 15 feet. From there, it's given to us that the weight can be expressed with this function. So we're going to write that down. And from there, we simply just have to simplify everything. And from there, what we're going to do is we're just simply going to plug in 15 to the x's, and then the second term is going to be 0. So from there, we know that's simply going to be equal to 0. And that should give you 2,962.5 pounds. But so we could put the resultant force is equal to 2,962.5 pounds. Or remember that 1,000 pounds is equal to a kip. Or we could rewrite that resultant force to 2.96 kips. And remember that this force is acting downwards. So now that we were able to determine the magnitude of that concentrated force, from there it asked us to determine the location of this resultant force on the beam measured from point A. So from point A, we have to determine how far out it is. So to determine the location of it, we're going to be using this equation, where the location is equal to the integral of x equals 0 to the length, or the span, of x, which is what we're trying to find. So this is like the distance times wx dx, which this is considered the force, all over our resultant force. So now we're going to plug in everything. 0 to 15, x times x squared plus 3x plus 100 dx all over our resultant force that we know that it's 2,962.5 pounds. So from here, we're just going to simplify. We're just going to solve. So if we distribute that x, we would end up getting x to the third plus 3x squared plus 100x dx over our resultant force. And then from there, we would end up getting x to the 4 over 4 plus 3x cubed over 3. That would get simplified out. That would cancel the 3's out. Plus plus 100x squared over 2. So that will just be 50x squared from 0 to 15. All over our resultant force. So from there, we would get 15 to the 4 over 4 plus 15 cubed plus 50 times 15 squared all over our resultant force. Because remember, if we were to then plug in 0 into each of these terms, that would just equal 0. So we're not going to write it out. And that should give you that the location of that resultant force or that concentrated force is approximately 9.21 feet away from point A. And just like that, we were able to determine the location of that concentrated force. So once again, this problem was asking us to determine the magnitude of the equivalent resultant force and to also specify the location. So to determine that magnitude of the equivalent resultant force, we use this equation right here, where x equals 0 all the way to the length of the beam times the force times dx. And then for the location, to find the location or the distance of the force from point A, what we did is, once again, we took the integral from x equals 0, once again, to the length, times the distance, x, times, once again, the force, all over our resultant force, and we simply plug that in, and that gave us the distance. Thank you guys so much for watching this video. If you guys liked watching this video, please feel free to hit that thumbs up button and also subscribe to our channel if you guys would like to see more videos like this.